Super Typhoon Dolphin has just done something almost no storm does. It has become a Category 5 equivalent super typhoon at the farthest east longitude ever recorded in the Northwest Pacific Basin, breaking a mark that's Stu D since 1968. Sustained winds are at 270 kilometers per hour, roughly 165 miles per hour, with a central pressure that has dropped to 910 millibars. That is a storm strong enough to erase entire structures from the map. And it happened in less than 36 hours. This is not a slow build. This is a storm that went from tropical storm strength to the most violent classification meteorologists have, to a Category 5, in about 3 days. Let's break down exactly what's happening, why it's happening now, who's in danger, and what the next week actually looks like. As of the most recent advisory, Dolphin is sitting roughly 330 kilometers south-southwest of Wake Island, grinding northwest at about 20 kilometers per hour. The Joint Typhoon Warning Center has it pegged at 150 knots of sustained wind, a full Category 5 on the scale the U.S. uses to measure tropical cyclones. Japan's meteorological agency, which uses a different wind averaging method, classifies it as a violent typhoon, their equivalent top tier. The eye is small and symmetric, somewhere around 18 kilometers across, ringed by a wall of convection so dense and so cold at the cloud tops that satellite analysts can essentially guarantee Category 5 status just from the temperature signature alone. When the eye itself starts warming toward 20 degrees Celsius while the surrounding cloud tops sit near -80, that combination is about as unambiguous a signature of a top-tier tropical cyclone as satellite meteorology gets. Forecasters expect Dolphin to hold this intensity for the next 24 hours, and some guidance even suggests a further uptick is possible before the storm begins a longer-term weakening trend. That means the peak wind speeds we're citing right now might not even be the ceiling. It's worth understanding how meteorologists even arrive at these numbers, because there's no weather station sitting in the middle of the ocean radioing back live wind readings. Instead, analysts rely on a technique that essentially reads a storm's temperature signature from space, comparing the warmth of the eye itself against the extreme cold of the surrounding cloud tops. The bigger that temperature gap, and the more symmetric the structure around it, the higher the estimated intensity. It's an indirect method refined over decades of comparison against aircraft reconnaissance data, and for a storm like Dolphin, sitting far from any inhabited coastline where Hurricane Hunter aircraft would be dispatched, satellite estimation is effectively the primary tool being used to track it in real time. There's also a classification wrinkle worth knowing about, because you'll see different agencies describing Dolphin in different terms. The Joint Typhoon Warning Center uses 1-minute sustained wind averaging, the standard used across most of the Western Hemisphere, the equivalent strength. Japan's meteorological agency uses 10-minute sustained averaging instead, a method that produces lower peak numbers by design, which is part of why JMA's official classification reads as violent typhoon rather than an explicit Category 5. Both agencies are looking at the same storm. They're just using different math to describe its winds, and neither is wrong. Let's put some real numbers on rapid intensification, because the phrase gets thrown around a lot, and it undersells what actually happened here. Earlier this week, Dolphin was sitting at tropical storm strength, nothing that would have made headlines on its own. Within roughly 24 hours, its winds jumped by close to 95 mph, putting it at 145 mph by the following afternoon. From there, it kept climbing toward its current peak, near 165 mph. For context, meteorologists officially define rapid intensification as a wind speed increase of 35 mph or more within 24 hours. Dolphin didn't just clear that bar, it nearly tripled it. Analysts tracking the storm have described it as the fastest-growing tropical cyclone this basin has seen since Typhoon Noru back in 2022, which itself was considered a landmark case study in explosive strengthening, getting mentioned in the same breath as Noru tells you how far outside the normal range this event sits. One visual detail from the satellite loops is worth flagging on its own. During the most explosive phase of intensification, Dolphin developed what forecasters call a pinhole eye. It's an eye only 6 to 7 miles wide, dramatically smaller than a typical mature typhoon's eye. A small, tight pinhole eye is one of the clearest visual signs meteorologists look for when a storm is undergoing this kind of explosive, compact strengthening, because it means the storm's rotation is concentrating around an extremely narrow, extremely intense core. Plenty of typhoons reach Category 5. What makes Dolphin different is where it did it. The storm reached Category 5 intensity near 166.5 degrees east longitude, breaking the previous record for the farthest east Category 5 formation in the Northwest Pacific, set by Super Typhoon Faye all the way back in 1968 at roughly 162.7 degrees east. That record had stood for almost 60 years. There's a second layer to how unusual this year has been. Dolphin is the third Category 5 super typhoon to appear in the Northwest Pacific Basin this year, the first time that's happened since 2015, and July 2026 marks the first time since 2014 that two Category 5 storms have thus formed in the same July. Only the third time that's happened in the entire historical record. Stack that against the fact that a separate Category 5 hurricane, Genevieve, spun up in the eastern Pacific less than 3 days before Dolphin reached its own peak. You start to see a basin-wide pattern rather than one freak storm. Every tropical cyclone is, at its core, a heat engine. It pulls warm, moist air off the ocean surface, carries that energy upward, releases it as the air condenses into towering thunderstorms, and uses the resulting pressure difference to spin faster. The warmer the water, the more fuel is available. The calmer the winds are aloft, what meteorologists call low wind shear, the more that engine can stay vertically stacked instead of getting torn apart before it can organize. Dolphin found both conditions in nearly ideal supply. Just days before its rapid intensification began, the ocean beneath its path was measuring between 29 and 30 degrees Celsius, several degrees above what's typically needed just to sustain a tropical cyclone at all. Wind shear in the same window was running only 5 to 10 knots, about as calm as the upper atmosphere gets in a tropical system's vicinity. That combination let Dolphin's structure lock together instead of getting sheared apart, and once that lock-in happened, the storm's growth became almost self-reinforcing. There's a bigger piece of context sitting behind all of this. 2026 is shaping up as a strong El Niño year, with current NOAA data putting the odds of a very strong or super El Niño developing between October and December at over 80%. El Niño years tend to load the dice for are exactly this kind of genesis pattern. Tropical cyclones spinning up unusually far east, over unusually warm water, with unusually low shear. Dolphin's own point of origin, tracking in from the Central Pacific as what was originally designated Invest 92P, is itself a textbook El Niño signature. To understand why El Niño matters this much, it helps to know what it actually does to the Pacific. During an El Niño event, the trade winds that normally push warm surface water westward toward Asia weaken, which allows a pool of unusually warm water to spread eastward across the Central and Eastern Pacific instead of ying-pinned near the Philippines and Indonesia where it typically sits. That shift changes where tropical cyclones have enough fuel to form in the first place. In a typical year, a storm attempting to organize this far east, closer to the international dateline than to the Philippines, would run into cooler water and probably fizzle before it ever became a real threat. In a strong El Niño year, that same stretch of ocean is warm enough to support Genesis, and in Dolphin's case, warm enough to support Genesis at a genuinely historic level of intensity. Meteorologists tracking Dolphin's ocean environment have described almost the entirety of the water ahead of its forecast track as record warm, with readings above 30 and in some spots above 31 degrees Celsius. That's not a marginal edge. It's close to the highest fuel readings this stretch of ocean has ever produced. The only factors capable of capping the storm's intensity from here are essentially atmospheric rather than oceanic. Dry air intrusion, an uptick in wind shear, or a structural hiccup during a future eye-wall cycle. The ocean itself is not the limiting factor right now. If you followed any of the recent updates on Dolphin, you may have seen references to an eye-wall replacement cycle. It sounds technical, but the concept is fairly intuitive once you picture it. Think of the eye wall, the ring of the most violent thunderstorms, circling the calm center of the storm, like a figure skater with her arms pulled in tight, spinning as fast as she can. As a storm intensifies, it's common for a second larger ring of thunderstorms to form outside that original eye wall. That outer ring can begin choking off T, inner one's supply of warm, moist air. The original eye wall weakens and often collapses, and the storm's peak winds can dip slightly during the transition. But once the outer ring finishes, tightening inward and becomes the new eye wall, the storm frequently resumes intensifying, sometimes emerging even stronger than before, since it now has a wider structural base to work with. Dolphin went through exactly this process on its way to Category 5 strength. Recent microwave satellite passes show the new inner eye wall becoming established, with fresh deep convection wrapping tightly around the core. Forecasters expect the eye itself to grow slightly larger following this cycle, which can actually improve a storm's structural stability and let it hold peak intensity for longer, rather than spiking briefly and immediately falling apart. That's part of why some meteorologists aren't ruling out Dolphin creeping even higher, potentially toward the 170 mph range, before it's done. Here's the piece of this story that actually determines how dangerous it gets for people on the ground: track. For now, Dolphin poses no immediate threat to populated land. It's still moving over open ocean, guided along the southwestern edge of a subtropical ridge on a general west-northwest heading. That steering pattern is expected to hold for the next several days without major disruption. A trough currently pulling through northern Japan will drift east and weaken over time, and while it will loosen the steering pattern slightly, Forecasters don't expect it to be strong enough to pull Dolphin northward and away from its current path. After roughly 3 days, the guidance calls for Dolphin to shift toward a more westward track, as a separate ridge builds in from Japan. That's the inflection point worth watching, because depending on exactly how that ridge builds and where it centers, Dolphin's eventual path could bend toward the East China Sea, curve up toward the Korean Peninsula, or track closer to southern Japan. Some longer-range model guidance has floated the possibility of Dolphin eventually approaching Japan directly, though forecasters are clear that this remains uncertain even in the latest advisories, and cross-track spread in the guidance is already widening the further out you look, on the order of 130 kilometers of uncertainty by day 3 alone. This is the part worth sitting with for a second, because it's easy to skip past. A forecast track is a probability, not a guarantee. Small shifts in a ridge that hasn't even fully built yet can be the difference between a storm that spins itself out over open water and one that makes landfall on a populated coastline. That uncertainty isn't a failure of the science. It's an honest reflection of how genuinely hard it is to pin down the exact path of a system this dynamic, a week or more in advance. Track guidance right now is described as being in fairly strong agreement for the first couple of days, which is reassuring, but that agreement erodes the further out the forecast window stretches, which is exactly what you'd expect given how far away landfall, if it happens at all, would be. Ensemble modeling that's been run out to RD the middle of August shows a wide spread of outcomes, with a meaningful share of those runs showing dolphins staying over open water and threatening nothing at all. That's not the same as a guarantee of a safe outcome, but it's a real model-supported possibility sitting alongside the scenarios where the storm approaches land. There's one piece of good news buried in the forecast. As Dolphin eventually comes under the influence of that second ridge system, it's expected to move into cooler water and a less favorable environment overall, which should start eating into its intensity. Some meteorologists are flagging historical context here. Only 4 Central Pacific origin storms have ever tracked far enough west to make landfall in Japan, and 2 of those occurred during a strong El Niño, which is exactly the environment we're in now. That's not a guarantee Dolphin won't be the 5th, but it's a data point worth knowing. Even though Dolphin isn't threatening a major landmass at this exact moment, it has already passed uncomfortably close to some extremely vulnerable communities on its way north. Micronesia sits directly in the kind of exposure zone that makes a storm like this categorically more dangerous than it would be for a mainland coastal city. Chuuk, Pohnpei, and Yap are low-lying islands, in places only a few feet above sea level. For communities like these, a storm surge of even a couple of meters isn't a bad flooding event. It can mean total inundation. Current assessments put roughly 1.2 million residents across Micronesia, Guam, and the Marianas within exposed coastal zones, facing life-threatening storm surge that could reach as high as 4.5 meters, destructive winds strong enough to remove roofs entirely, and rainfall totals exceeding 500 millimeters, capable of triggering landslides on top of the flooding itself. Local authorities across Guam and the northern Mariana Islands have already activated evacuation zones as a precaution, and officials are expecting airport closures and supply chain disruptions to intensify over the next 48 hours. Emergency planners have been reviewing shelter capacity because when a storm intensifies this fast, the margin for error shrinks dramatically. You cannot wait until the storm is at your doorstep to start preparing. By the time its full strength is obvious on satellite, the response window has already narrowed to almost nothing. The standard guidance being pushed out to residents in the potential path is worth repeating plainly, because it applies regardless of exactly where Dolphin's final track ends up. Board up or reinforce windows. Secure or bring in anything loose outside that wind could turn into a projectile. If a structure isn't built to withstand sustained winds in the range, Dolphin is currently producing. The safest place to be is the lowest interior room, away from windows and exterior walls. And if local authorities issue an evacuation order, the instruction from every emergency management agency covering this region is the same. Do not shelter in place once an evacuation has been ordered, because storm surge and structural failure at this wind speed can overwhelm a building far faster than flooding alone would suggest. It's also worth noting that this region isn't unfamiliar with typhoons. The wider basin averages around 25 named tropical cyclones a year, and warm season intensification between July and October is the norm rather than the exception. Hat makes this event different isn't that a typhoon is approaching the region. It's the speed and ceiling of the intensification and the fact that it's happening in a year already producing an unusual cluster of top-tier storms. Every time a storm intensifies this quickly, it becomes a case study for a bigger question that scientists have been chasing for years. Are our oceans becoming more efficient at producing extreme tropical cyclones? The honest answer is nuanced, and it's worth resisting the urge to flatten it to a single headline. Researchers who study ocean heat content, not just surface temperature, but the warmth stored in the layers of water beneath it, have documented a long-term rise in the fuel available to tropical cyclones. Warmer oceans that just mean warmer surface water. They mean deeper reservoirs of heat that a storm can tap into even as it churns up the ocean and pulls cooler water toward the surface, a process that would normally choke off a storm's fuel supply. When the deeper water is also unusually warm, that natural braking mechanism doesn't kick in the way it should, and the storm just keeps feeding. Climate researchers, including those at NOAA, have been careful about how they frame this. No single storm, including Dolphin, can be attributed directly to climate change. That would be an oversimplification the data doesn't support. But the broader trend is harder to wave away. The odds of rapid intensification events, the exact kind Dolphin just demonstrated, appear to be climbing as ocean temperatures rise. Longer-range climate projections tied to this basin estimate a 5 to 8% increase in Category 4 and 5 storm frequency by 2050 due to ocean warming. That's not the same as saying every season will produce a monster storm. It means that when the right ingredients line up, warm surface water, a deep reservoir of heat beneath it, and a stretch of weak wind shear, the results can escalate faster than almost anything in the historical record prepared us for. It's also worth separating out the El Niño effect from the long-term climate trend, because they're doing two different jobs here. El Niño explains why this particular season is producing storms that form unusually far east of, or unusually warm water. The long-term ocean warming trend is a separate, slower-moving factor that raises the baseline odds of rapid intensification across almost every season, El Niño or not. Dolphin is arguably a demonstration of both effects stacking on top of each other at the same time. There's a mechanical reason a warming ocean specifically favors rapid intensification events, rather than just producing slightly stronger average storms. A tropical cyclone's own rotation churns the ocean beneath it, pulling cooler water up from depth toward the surface, a self-limiting feedback loop that, under normal conditions, cuts off a storm's fuel supply just as it's trying to intensify fastest. That's part of why many storms top out well below their theoretical maximum. But when the warm layer extends deeper below the surface, that upwelling process keeps delivering warm water instead of cool water, and the natural break never engages. The storm keeps intensifying instead of self-limiting. That's precisely the ocean heat content pattern researchers have flagged as trending upward across multiple basins over the past several decades, and it's a big part of why events like Dolphins are becoming both more frequent and harder to forecast with confidence days in advance. None of this means every storm from here forward will behave like Dolphin. Most won't. Most tropical cyclones still follow the slower, more gradual intensification curves the historical record trained forecasters to expect. But the outlier cases, the ones that jump 95 km/h in a day, that hit Category 5 farther east than any storm on record, that stack 3 or 4 of themselves into a single basin in a single season, those outliers appear to be showing up more often than the older climatological baselines would predict. That's the actual finding driving the scientific conversation right now, and it's a more careful, more limited claim than climate change caused this storm. It's closer to climate change appears to be loading the dice toward more frequent extreme outcomes without determining any single role. Over the coming days, there are 3 specific things forecasters are watching that will determine how this story actually ends. First, the intensity ceiling. With the eye wall replacement cycle nearing completion, and the eye reportedly stabilizing into a slightly larger, more resilient structure, there's a real chance Dolphin ticks higher before it starts to weaken. Some guidance puts the outer edge of possibility near 170 millibars. Second, the wind shear environment ahead of the storm's path. If Dolphin moves into a zone of stronger upper-level winds, the same structure that let it explode in strength could start getting torn apart, the same way it was built. Third, and most consequential, the behavior of the ridges of high pressure steering the storm. These systems are invisible to the naked eye, but fully visible on every weather model, and they are what will ultimately decide whether Dolphin approaches southern Japan, bends toward Korea, drifts into the East China Sea, or simply spins itself out over open water without ever threatening a populated coastline. Super Typhoon Dolphin is, right now, one of the strongest storms on the planet. A Category 5 equivalent system that broke a nearly 60-year-old record for how far east a storm this powerful has ever formed in this basin. One of at least 3 Category 5 super typhoons this basin has produced in 2026 alone, in a year already shaping up as a strong El Niño season. It is not currently threatening major population centers, but it has already put Micronesia, Guam, and the Northern Marianas on evacuation footing, and its eventual track toward Japan, Korea, or open water remains genuinely uncertain even in the most recent forecast models. What happens next depends on ridges of high pressure that haven't fully built yet, wind shear patterns still taking shape, and whether Dolphin's newly reorganized eye wall has one more burst of intensification left in it. We'll be tracking every update as this develops.